Okay, so let's start. Uh, Please let me know if my screen is visible. Is my screen visible?
Yes, sir.
Okay. Okay. So yesterday we studied about just an intro to supervised learning, unsupervised learning, reinforcement learning, and looked into two class of model in supervised learning. One was linear regression and logistic regression. And both these algorithms require, we did not actually study both these algorithms, how to train these algorithms, but we just looked into each of their fundamentals, that what are they trying to do. So linear regression was a regression problem, logistic regression was a classification problem. But to develop the more mathematical intuition, we need to first go over some basics of linear algebra, and we'll do some Python programming with linear algebra today. And hopefully, by the end of this class, we all will be familiar with the mathematical requirements that we will need to understand logistic regression and linear regression. And tomorrow, we will look into the proofs and we'll look into the math behind logistic regression, linear regression. Okay, so before I continue, how many of you are familiar with linear algebra? Like, just raise your hand. You don't have to say yes, no. If you can just raise your hand, in so that I know that how many of you are familiar with linear algebra. Mm, okay, it seems like not many people are familiar with linear algebra. Okay, so let's look into linear algebra once. So linear algebra. So here we will just be talking that it's not complete linear algebra. We'll just be taking some of those concepts. We'll just review some of those concepts once, and just only focus on few of these parts, and the remaining will do. We will actually look into those other concepts if and when we require later in the course. So we'll just look into the scalar, what are vectors, how are matrices constructed, what does each of these terms mean, how do we do vector matrix calculation, what is identity matrix, when will the inverse of a matrix exist, and what does it mean to have an inverse of a matrix, how do we solve linear equations, what does rank of a matrix means, and eigenvalues and eigenvector if time permits. Okay, so let's see. So what a scalar is a singular number though. So for example, if you have example could be a speed of a car or the light's intensity. So intensity could be is some number, right? The scalar is a singular value in some real number space that gives some information, that gives a measure of some concepts. So here the speed is a concept and you want to measure the speed of a car. It is a singular number. Light intensity, you want to measure intensity of a light. It's a singular number. So any such singular number that describes some properties of uh, some instance x, that is a scalar number x. So a scalar is just a single number. And a vector, you can think of there are multiple scalar vectors arranged in some order to describe some quantity. So, for example, remember the yesterday's class that we looked into, that we had a person P. Sorry, this is stupid. We have this person P person was given by this vector with age was there. Oh shit! Writing in this is also difficult. Age was there. There was what was it? The dressing sense was there. There was cloth, something else. There are many other quantities, right, to describe the person. So we have these different features there. All these features together was representing a single person P, right? So something of similar category. So if you have a vector, it simply means there each of these term is a scalar value which measures some characteristic of this uh, of this variable x. So x is some instance, and this x, so let's write it x bar. It measures some properties of this x bar is represented by this vector, and each of these instance x1, x2, x3 are simply uh, some feature of this x bar. Till this point, is everyone with me? Okay. So yeah, so this is what vectors are. So scalar and vectors, this is what they are. Now in matrix, could be just but I can say grouped vectors. So there are, like, say, in matrix A, we have one vector, two vectors, and three vectors. So three vectors grouped together are matrices. And it does not necessarily mean that each of these matrices will have some meaning or so. But in general, these matrices you can think of that these are data, like a group of people information in a matrix form. So this is person one information, person two information, person three information. In some form, it has been grouped to form this matrix A. But not necessarily all matrices will have some meaningful value. Matrices are just vectors arranged in a vertically arranged form. So these are vector 1, 2, 3, and they have been arranged. So we have 3 rows and 3 columns in a matrix A. So this is how do you know? You just simply count how many columns are there. 1, 2, 3. And how many rows are there? 1, 2, 3. So in A matrix, we have a 3 by 3 matrix, and we call this kind of a matrix as a square matrix. Why? Because we have equal number of rows and equal number of columns. So in matrix C, how many rows and how many columns are there? In matrix C, how many rows and how many columns are there?
3 rows, 2 columns.
Okay. So we have 3 rows, 1, 2, 3, and 2 columns, 1 and 2. So we have 3 rows and 2 columns, and that's how we call it a rectangular matrix of size 3 cross 2. So similarly, a vector is a n cross 1 matrix. Remember this vector? So there are how many rows and columns in this? So in this x vector, how many rows and columns are there?
3 cross 1, sir.
Yeah. So 3 cross 1. So vector is simply a n cross 1 matrix. So you can visualize vector in a matrix form, and matrix is a very general form. So how will you describe a scalar? So if I have just x1, that's it. What is the size of this matrix? Just x1. What is the size of this matrix? X1. What is the size of this matrix? Can someone say? Oh, this is simply 1 cross 1, right? Hello?
Yes, sir.
Okay. Okay.
Uh,
So it's just there is only one element and one row and one element. So it's 1 cross 1. In general, 1 cross 1, no, it does not have such significant meaning, but you can see the matrices is a general form of writing any scalar, any vector into a matrix representation form. Okay. So let's now move on. Sorry. Hmm. So we have this matrix, and D is a matrix. We call each of these elements. So we have this D11. So just a sec. Let me just choose a different color, right? So we have this D11, D12. It simply means that this is the element number D11. So Dij means the ith row and jth column. Okay. So ith row and jth column. So in C matrix, what is C? Let's call it 1, 2 with this definition. So what is C12 here? What is the value of C12? C is this matrix.
4, sir.
Okay. So C12 is 4, right? So now similarly, and what is the value of A33?
4, sir.
Okay. So people are able to see, right? So what does each of these matrices mean, and how does each value you can estimate? So whenever you see this number Dij, you can read it. What does it mean? So you are reading I starting from here and J starting from here. So in general, in machine, in Python or so, you will read the starting values not from 1 but from 0 though sometime. And rather than if it starts with 0, it is D00, D10, and D20. Okay, because it is starting from 0. So this is also there, like it's just that the starting index is now not starting from 1, but it is starting from 0. So this is just a notational thing, but in general, this is how it is read. Okay. So this part is okay. Okay. So let's move on. So this is what matrices are. Now, what is transpose of a matrix? First, let's look into transpose of a vector. So you have a B as a vector, and if you apply transpose over here, it becomes this. So it just simply flips the column into row, right? And similarly, if you have a row vector and if you apply transpose to it, and it flips the row into column. This much is okay?
Yes, sir.
Okay. So now if you apply a matrix transpose, it converts each row into a vector. So each row into a column. So you have this row vector 1, 2, 3, and it will convert into a column vector 1, 2, 3. And 5, 4, 1 will get converted into 5, 4, 1. The third element 6, 7, 4 is also converted to 6, 7, 4. And also note, not just in the row form, you can also do it in this form too. 1, 5, 6 is column and it becomes a row here 1, 5, 6. See, 2, 4, 7 is a column here and 2, 4, 6 here becomes the row. 3, 1, 4 is a column here and 3, 1, 4 becomes a row in the transpose. Okay.
Okay, sir.
Okay. So now I have a very interesting question. What is the transpose of this? What is the value of this? What is the value of this? How many of you feel like the answer should be this? It should not change. It will remain the same. So whether you apply transpose, it still remains the same. How many of you feel this is the correct answer?
Samay, sir.
Huh?
Sir,
Or you
2
think?
will be the correct answer because 1 cross 1 matrix, sir.
Okay, so this you think that this is the correct answer, right?
Yes,
Yeah.
sir.
So this is indeed a correct answer because it's a 1 cross 1 matrix, and if you transpose, it remains the same. Okay, so now let's do something more interesting. Now let me see if I can select. Okay. So now tell me what is the transpose of this. Say we call B, this matrix is B. B is equal to, this is nice, 2, 0, 0, 5. And what is the value of B transpose? Now tell me, what should I write? What is B11? What should I write? What should I write B11?
2.
2, sir.
2. B1 2. B12,
0, sir.
0. B21, 21.
0, sir.
Okay. And this value?
5.
B22. Did you see something interesting? B transpose is actually equal to B. Right?
Yes, sir.
Can we also say, is A transpose equal to A? Is this true? A transpose is equal to A? Like, say if not A transpose, say, wait a sec, let me write. So, can we say for any C matrix, can we always say that C transpose will be equal to C? Like, C is some matrix. Some matrix you bring, any matrix you bring, if I do transpose, it will become C. You saw that 2 transpose became 2. You even saw B transpose became B. Can we also say that any C matrix, if you transpose it, it will become C? Is this the correct statement?
No, sir.
Why?
Sir, for any values, it's not support because based on that value of the matrix that will place.
Yes. So you can see an example here itself, right? You can see A is not equal to A transpose. A is some this number and A transpose is something else. It is not. Only the diagonal 1 first matches and 2 and 5 does not match. 3 and 6 it is not matching. So A transpose is not equal to A. And not just this, what if it's a, forget about matrix, if it is a column vector, it's a column vector, and this is not equal to row vector, right? The y is there, but here it is not, there is no column here, it's a row vector here. So B and B transpose is not equal. Similarly, D and D transpose is not equal. Because it is, what is the size of this matrix? What is the size of D? What is the size of
So
D?
1 cross 3.
1 cross 3. And what is the size of D transpose?
3 cross 1, sir.
3 cross 1. So you can see that the matrix D and D transpose are not equal. Even though you feel like the numbers are equal, the matrix size is entirely different. It is like saying that, oh, okay, it's the sizes are also different, so they are not equal. So any matrix C is, if you transpose it, it is not necessarily it will become the same. So when will it become same? When will you say that any matrix, say some matrix D is equal, D transpose is equal to D? When will you be able to say this is a true statement? When will it be always true, be true?
Adjacency matrix, sir.
Adjacency matrix. Yeah, you can say such thing, but we have not done such thing currently. Can you give me a very slightly easier example? My adjacency, I'm saying that it is correct answer though. I'm not saying it is not a correct answer. It is correct answer. Okay, so let me, for those who don't know adjacency, we will not take adjacency, but let me give you a very even easier example. Like if you have, say, 1, 2, 3, and everything is 0, 0, 0, 0, 0, 0, and 0. So say if this is a matrix, its transpose will be same,
Yes, sir.
right? So you can see that if the matrix is a diagonal matrix, only the diagonal elements are there, and everything else is 0, its transpose will always be the same, right?
Sir, this
Can
is
you?
the identity matrix.
No, it's not an identity matrix. It is the diagonal is there. 1, 2, 3. Some numbers are there. Identity matrix. We will see what identity matrices are, but it is not an identity matrix.
Okay, sir.
So if it's a diagonal matrix, any number, so not just 1, 2, 3. Like say I will make it 4, -2, and 8. Its transpose is also the same. Can you see? Right?
Yes, sir.
Yes, sir.
So not just a 3 cross 3 matrix. If you even if you have 100 cross 100 matrix too, like the size the 100 cross 100 matrix, and if only the diagonal elements are there and everything else is zero, like this is zero, and only the diagonal is there, and even if it is a 100 cross 100 matrix, its transpose will also be same. Can you at least visualize, mentally visualize this thing that even if it is a diagonal matrix of very large size, its transpose is always going to be same, right?
Yes, sir.
Yes, sir.
Okay, so a very simple example. Any diagonal matrix, its transpose is always same. So D transpose D is always same for a diagonal matrix. But it is not the prop. There are many other matrices too, like adjacency matrix that someone pointed out, that its diagonal, its transpose is also the same. But we will come to those part later. But currently we'll just what is the main property for what kind of a matrix will always have this. There is a nice form though, that if you have a matrix in this form, it will always be same, but we will learn all those things today in today's class. So till this point is okay, right? Currently we have seen one matrix form, a diagonal matrix, which have, if you transpose it, it's always the same. We'll see other matrices in as we go in this lecture. Okay, so we go now. Okay, so there are other things that we must do. So this was transpose. Now we have addition. So A plus B matrix is equal to B plus A. So however you add, so you have this. Oh, okay, this way we have an example. 2, 4, 5, 6, and 1, 0, 0, 1. You add them, you get 1 plus. Okay, there should be an equal sign here, not multiply. So 2 plus 1, 3. 4 plus 0, 4. 2 plus 3, 5. 5 plus 1, 6. Is this okay? A plus B is this matrix. And even if you switch, like if you make B plus A, you can see it is the same value, right? Can everyone see that A plus B and B plus A is always same? Whether you add A plus B or whether you do B plus A, it's always the same thing. Only this part. Can everyone see this?
Yes, sir.
Yes, sir.
Okay. So now let's do an exercise though. Now tell me what would be A plus B here. So let's say 1, 2 plus -1 -1. What would be the value of this? What should I write? First number.
0, 1, sir.
0 and 1. Can everybody see this thing?
Yes, sir.
Okay. So now let's do another exercise. Now tell me what is the value of this. 1, 0, and plus 1, 0. What is the value of this? What should I write?
Sir, both matrix have the same size, then only we do the addition, sir.
Okay, so now you have noticed something interesting, that this addition is only possible. You forget about A plus B equal to B plus A. You can't even add these matrices. You can only add A plus B when A and B are of same shape or same size. So if A is say n cross n matrix. Everyone is with me, right? What is M? What is N? Can you tell me what is M here?
Sir, row column, sir.
Okay, row and column. And B is say P cross Q. So when can you add these two matrix? What is the condition? When M is equal to P.
P, sir.
And N is equal to
Q, sir.
Q, sir.
Q. Is everyone able to see that you can only add a matrix A and B only when M and P are equal and N and Q are equal? That means that both these matrices are of same size. You can see this, it is 2 cross 2. This is also 2 cross 2, and then only you are able to add. When I gave you this matrix 1, 0, and this, can you add this matrix too? I just changed the direction though. Can you add these two?
No, sir.
You can see that you cannot add because the size. What is the size of this matrix? This matrix
1 cross 2, sir.
1 cross 2, and this one
2 cross 1.
2 cross 1. So you can see that the sizes are different. Even though the numbers looks very easy, that oh, they have only 2 elements, but you cannot add them. Okay. So you can only add matrices A and B when they have the same size, and if they have the same size, you can always switch which one you want to add first, A plus B or B plus A. Then they will be always be equal. This is okay. This is so difficult to write. Okay, as if to say I wrote equal here. I don't know which language it is equal, but yeah, it is equal. A plus B is equals to B plus A. And similarly, if you see this A plus B plus C, you can also break it and write A plus B plus C. This is called associative. So you do A plus B and then add C, or you can do B plus C, which is B plus C, and then add it to A. So all these are valid transformation. That the answer will remain the same. Everyone is able to see this thing, right?
Yes, sir.
Okay. Now, can someone tell me when can you do all these things? What is the condition on to do all these things? What is the condition on A, B, and C? Say A has M cross N, B is P cross Q, and C is assume X cross Y. So M should be equal to what?
Sir, P and X.
P and X. P equal to X. All these things should be equal. Is
Yes,
this what you
sir.
said? Okay. And N should be equal to what?
Q, then Y, sir.
Q and Y. Is everyone able to see this thing?
Yes, sir.
So if you do not have this condition, it must be this. Otherwise, if anyone breaks, like say if C is some other size, you cannot do addition there. Right?
Yes, sir.
Okay. So if everyone is able to see, so this is what addition is. Addition requires all the matrices to be of same size. Otherwise, you cannot add. Chalo. This is what addition is. Next, subtraction. Subtraction is very easy. Similarly, if you just have to add minus here, and then it becomes that you can put minus here, and you can push all the minus to everything, and then you do addition. You see? And this minus went inside in all the terms of B. So you can think of A minus B as A plus minus of B. Minus B matrix is just minus on everything. Okay, this part.
Okay, sir.
Okay, now what is the condition on A and B? If A is M cross N and B is P cross Q, what is M equal to?
P, sir.
P.
P, sir.
And N is equal to
Q.
Q. So even subtraction requires to be of same size. You can see that you can always convert any subtraction into an addition matrix, and if it is an addition, it must satisfy, it must be of same size, otherwise you cannot add. Similarly, you can say if you want to subtract, it must be of same size or else you cannot subtract. Everyone is clear with this?
Yes, sir.
Okay, so let's move to, I think we have a lot more things to talk. Okay, now scalar multiplication, we have this matrix M, and when you multiply lambda, it simply means that you take all this scalar value. Lambda is some scalar, some constant, and when you multiply, it will just simply go inside everything. Okay? Now, can someone tell me what would be the value of this? 1, 1, and if I multiply by 100, what should I write? Is this correct answer? 100? Just tell me, first tell me if this is correct answer. Is this the correct answer?
No, sir.
Why? Can you tell me why did you say that this is not a correct answer?
Sir, the left hand side has 2 row, but the right hand side has 1 row, sir.
Ah, this is right. So the size of this matrix is 2 cross 1, and the size of this matrix is 1 cross 2. How did you, what kind of a multiplication is this, that by multiplying you change the size of the matrix entirely? Acha. What about this? If I write transpose here. Now, is this a correct answer?
Yes.
Yes, sir.
How
Yes,
many
sir.
of you believe that this is the correct answer and I don't have to explain? Anyone who wants me to explain this, that this is a correct answer now. Suddenly this became a correct answer now. Just by adding a transpose here, it became a correct answer. Does anyone need me to explain how it did become? Okay, everyone is smart here then. So everyone is with me, right, till this point? I'm assuming the answer is yes. So this is what it is. So if you multiply with a scalar, it does not change the shape or anything. It will just simply take the element and you just simply multiply each element with it. As you saw here, we have this 100, 10, 10 cross 10, and if you multiply with 2, it should not change the shape of it. It will simply become 20 and 20. So the size of the matrix is m cross m here. Say if this matrix is size m cross n, the final size will always be p cross q. What will be the final size? Will always be m cross n, right? If you multiply any scalar with a matrix A, the final resultant matrix B will always be of same size, right?
Yes, sir.
Okay, if people are not able to see this thing, or do I, let me explain it properly then. Say you have this matrix A, some matrix A, and you multiply with some scalar lambda. Let's not write lambda. For the time being, just say multiply with, say you multiply matrix A with 10, and you get matrix B. Okay, so now if A is of size m cross n, and B is of size p cross q, m is equal to q. Is this correct? Did everyone drop the class? No, no, there are people here. So is this correct?
Yes, sir, because the scalar is multiple with.
So is this correct? This is correct? Yes, right? You said yes. And
Yes, sir.
n is equal to p. So this is what you're saying, right?
Yes, sir.
Yes, sir.
How many of you think that this is correct, and how many of you think that this is not correct? Is everyone thinks that this is correct? I don't have to explain. Or is there anyone who thinks that this is not correct? Yeah, something is wrong in this. Anyone? Okay, no one thinks this is wrong. Everyone thinks that this is correct.
Sir, M equal to P, N equal to Q, sir.
So there is one answer which says that, okay, one contender that m is it should be equal to p and n should be equal to q. Otherwise, this is what someone is proposing. So we have answer 1 and answer 2. Actually, the answer 2 is correct. And you can see this thing from here. What is the size of this matrix though? Can someone tell me the size of this A, B, C, D, E, F matrix? It is 2 cross
3, sir.
3. And what is the size of this matrix?
2 cross 6.
2 cross 3. So when you multiply with any scalar number, it simply goes inside and multiply with every other element inside it. It is not changing the shape of the matrix, right? So similarly, if you multiply with 10 or any number, why will it change the size of the matrix B? It must be, M should be equal to P and N should be equal to Q. It must be this, right? It cannot be anything else. Is everyone with me?
Yes, sir.
Yes, sir.
Okay. So the person who answered this question, remember this 1, 1, and you have this 100, when we multiply 100 with it, and I wrote this number 100 here and 100 here, and people said that, oh, this is incorrect because I changed the shape of this matrix. It was 2 cross 1, it was 1 cross 2. A scalar multiplication cannot change the shape of a matrix, and hence this is not correct. Even though 100 is correct, but this is not correct. This is not correct. Not equal to. But it suddenly became equal to when I added transpose. Why? Because then this when you do this matrix transpose, it became 1 cross 2. And then when you multiply 100, it becomes 1 cross 2, and then it became equal. Is everyone with me till now?
Yes, sir.
Okay. So this is matrix multiplication. So we saw scalar multiplication. Now let's see matrix multiplication. Matrix multiplication is slightly more involved. So you have two matrix A and B, and you multiply A is of size M cross N and B is of size K cross L. A and B multiplication is only possible when N and K are equal. And the resultant matrix will simply become when N and K are equal. So you can the matrix will become M cross L. And how do you multiply is slightly involved. So you take this element, say the first element here, and you multiply with this element. Okay. And how do you multiply this element? Do we have an example? We have an example. So how do we multiply this? Say you have this A, let's take a very simple example, 2 cross 2 matrix. B is also 2 cross 2. So this is 2 cross 2. This is also 2 cross 2. So this is M cross N, and this is K cross L. So you can see N and K are equal to 2, right? So matrix multiplication is possible. Is everyone with me, right?
Yes, sir.
Okay, so now how do you multiply? So you take each element 1 into 2, 1 into 2, and 0 into 3, 0 into 3, and then you add them. This is one element. Similarly, when you want to find the second element, C12, you take 1 into 1 plus 0 into 1, 1 into 1 plus 0 into 1. Similarly, if you want to find C21, you take 2 into 2 plus 3 into 3, 2 into 2 plus 3 into 3. If you want to find C22, you do 2 into 1 plus 3 into 1, 2 into 1 plus 3 into 1. Can everyone see the matrix multiplication?
Yes, sir.
Okay, so now there is another question for you. If I have this matrix, do you have more interesting things? There are, okay. So say we have 1, 1 into 1, 1. Can we multiply these two? And what if we can, then what is the value? First, can we multiply? Is multiplication is possible?
Yes, sir.
Okay, and why is this multiplication possible? Because the size of this matrix is 2
2
cross
cross
1,
1, then 1 cross 2. So n equal to k, sir.
n equal to k. And what will be the value? Now help me write the value. First element C11, say C11. What is the C value? First value. What should I write here?
1 into 1, sir.
1. Okay, second element. Let's
1
make it
into
more
1.
interesting. Hey, I think let's make it more interesting. So let's write 2 and let's write 3. Otherwise, it will become same numbers. So what should I write here? This is 2 now and this is 3. So what should I write here? Second element?
2, sir.
2. And this element?
3, sir. 3, sir.
3. Another element?
6, sir. 6.
Anything else that I should write? Or is this enough?
2 plus 2 is the final answer.
This is the final answer. And you can see the matrix is 2 cross 2. When n into n and k are equal, the matrix become m times L. Right? This is what we saw. The final matrix size is m cross L. And we have m cross L, 2 cross 2. So everyone is okay with this form, right?
Yes, sir.
Now let's do one more example. Now tell me what is this value? 1, 0 and cross multiply with 1, 0. What is the value answer for this? What should I write? First number.
I think this is not possible because n not equal to
So what is the size of this? This is
1
1
cross 2.
and this is also 1 cross 2. And you can see n and k are not equal. They are not equal.
Yes, sir.
Therefore, the matrix multiplication is not possible. This is not possible. This is so difficult. Not possible. I'm assuming everyone understood my handwriting though. This is not possible. Okay, so this is what matrix multiplication is. Now let's go to another part. So there are matrix multiplication. It means that A times B is not generally equal to B times A, because it can be M cross N and it can be N and K should be equal, but it is not necessary that when you inverse it, like reverse multiply it, it will in general not be possible. Sometimes a B cross A may not be possible. So in general, you cannot say A times B is equals to B times A. Correct? And similarly, but in matrix multiplication, you can always do this thing though. You can multiply BC and then multiply with A, and it is equal to, say, you can multiply A and B and then multiply with C. This is correct. This is possible. But this is not possible. Okay. So I will leave this homework to just see yourself that this is actually possible, but this is not possible. You try with any random matrix, create a random matrix A and B, and you can switch signs and see this is not possible and this is possible. Okay. And similarly, we can mix addition and multiplication too. So you can add B plus C and then multiply with A, or you can do A into B plus A into C. They are both equal. So A into B plus A into C. And similarly, you can reverse also do the same thing. So you can add these two and multiply, or you can pass C inside and you can do A into C plus B into C. I will leave both these three. There are four things, 1, 2, 3 and 4, to verify yourself that all these things are possible. Only A into B is not equal to B into A. Okay.
Okay, sir.
Okay. So I will not be able to do example because I think I have a lot more things to cover and only half an hour is remaining now. So, but I will leave this for you to verify yourself. Let's do some more other interesting things now. So we have this vector product now. So vector product is very similar to matrix product that you do it. Now you have two vectors, x is a vector and y is a vector. Vector simply means that you have n cross 1. N is the number of rows and 1 is the number of columns. If you have one column, it is called vector. That's what it is. It's just a definition though. You can call anything, but this is just a name of, we will call vector as one column element. If you have one column, that we will call it a vector. So you have two vectors, x and y, and the vector product simply means x transpose y. So what it means is you cannot do x into y, right? Because x is of size, say, 3 cross 1 and y is also of size 3 cross 1, and n is not equal to k, so this multiplication is not possible. But if I do x transpose y, is this multiplication possible? Is this multiplication possible? X transpose y multiplication possible? X is this and y is this.
Yes, sir. Because
It is possible. If the x transpose became 1 cross 3 and y is 3 cross 1. X transpose shape is 1 cross 3 and y is 3 cross 1. And now n and k are equal and it is possible. The resultant matrix, say it becomes Z, and what is the size of Z?
1 cross 1, sir.
1 cross 1. And 1 cross 1, we saw it's a scalar, right? Remember when we defined scalar, vector, and matrix? So 1 cross 1 simply became scalar, and that's what it becomes. So you have know how to do multiplication. So you have x1, x2, x3, and y1, y2, y3. So x1 into y1, x1 into y1, plus x2 into y2, plus x2 into y2, plus x3 into y3, plus x3 into y3. And this became a single value, which is a scalar value. And this is a nice way of writing summation over xi, yi, I going from 1 to 3. So this is just the short form of writing this thing. So everyone is okay with this part?
Yes, sir. Okay, sir.
Okay. Now let's do something interesting more. So we have this X matrix. So we have this X matrix. Is this, and if I do Y transpose, is this possible? Is this correct? Is it possible? Can you multiply this to X into Y transpose? Your X is this, Y is this.
Yes, sir, because n equal to k.
Okay. So X is currently 3 cross 1. Y transpose is also 1 cross 3. Is everyone able to see Y transpose is 1 cross 3? Y is 3 cross 1. Y is 3 cross 1 and Y transpose is 1 cross 3. And N and K are equal. So the resultant matrix Z would be 3 cross 3. Right? Because
Yes,
N
sir.
get cancelled and M cross L will become, so M 3 cross 3. Now how will you do? It's very simple. We did this thing before. Actually, we did it one slide before itself. So X into Y transpose, you take X1 into Y1, X1, Y1, because there is nothing to add anything. So X1 into Y1 and X1 into Y2, X1 into Y2, X1 into Y3, X1 into Y3. Similarly, X2 into Y1, X2 into Y2, X2 into Y3, and so last X3 into Y1, X3 into Y2, and X3 into Y3, and you have 3 cross 3 matrix. This is 3 cross 1, this is 1 cross 3, and it became 3 cross 3 matrix. Everyone is okay with this?
Yes, sir.
Okay, sir.
Okay. So this is what vector product is. Now let's last example though. So we have yeah, this is bad. Say we have matrix A, vector A of size say m cross 1, and we have a vector B of size n cross 1. Now tell me, what is A transpose B? What is the value? Is this possible? What is the size of the matrix? A transpose B is equal to C. What is the size of the matrix C?
Sir, not possible, I think, because M and N are unknown.
Say M is some number. So assume M and N are some number, but they are not equal. M and N are some number, but they are not equal. There are some number. Say M, you can think of M as 100 and you can think of 2. Some number, but they are not equal. Is this possible? And what is the size of C? Okay. Since A transpose becomes 1 cross M and B becomes N cross 1, you can only multiply when M and N are equal. If M and N are not equal, you cannot multiply, right?
Yes, sir.
So this multiplication, and since I said M and N are not equal, that means multiplication is not possible. You cannot multiply these two. Correct?
Yes, sir.
Yes,
Okay.
sir.
Now let's do this again. Your A is M cross 1 and B is N cross 1. Can you do A into B transpose? Is this possible? And what is the size of the matrix C? Here again, M and N are not equal. What is the size of C?
M cross N, sir.
1
In this
cross 1.
M cross 1, we have M cross 1, we have M cross N. Anything else? N cross 1?
Sir, 1 cross 1.
1 cross 1. We also have 1 cross 1. Anything else? Now let's write it. So A is M cross 1, B transpose is
1 cross n, sir.
1 cross n. And now tell me what the matrix multiplication is possible?
Yes, sir, because n equal to k.
N equal to k, 1, 1. Now the resultant matrix should be 1 m cross 1 and m cross n or 1 cross 1.
M cross
m
N.
cross n.
M cross n. So whoever said m cross n is the correct answer. Okay? Everyone is able to follow the switch, right?
Yes, sir.
Okay. So this is how you should see matrix product, vector product, matrix vector, when it will become suddenly becomes scalar and all those things. Now let's look into identity matrix. This is even more interesting though. So identity matrix is a matrix which have all the diagonal elements equal to 1. Remember the diagonal element that we did? D transpose is equal to D. All the diagonal elements were same. So D transpose was equal to D. Like, okay, if let me just try recalling. So we have this 1, 0, 0, and 2. And we did the transpose of this and we found out that oh, it is actually equal to the same matrix. 1, 0, 0, and 2. Right? So why we call it a diagonal matrix? Because only the diagonal elements were there and everything else was 0. That's why we call it a diagonal matrix. Right? And in identity matrix, all the diagonal elements are 1. They are not different, they are all equal to 1. So if you have a diagonal matrix with 1, it's called an identity matrix. Is everyone okay?
Okay,
Yes,
sir.
sir.
Yeah. So this is what identity matrix means. And they have a very interesting property though. The property is that when you multiply, okay, let's do an example though. We will see with an example. Say you have a matrix of size 1, 2, and another 1, 0, 0, 1. So this is your identity matrix. You can see the diagonal elements are 1 and everything else is 0. So this is an identity matrix. And the answer would be, first, is the matrix multiplication possible? Now I will not write the numbers, the size, everything. You tell me whether it is possible or no. Yes, no.
Yes, sir, possible.
Yes. Okay. So what is the first value I should write? If it is possible, the first value, what will become first value? So 1 into 1 plus 2 into 0. So it becomes 1. Right? 2 into 0 is 0. So 1 into 1 becomes 1. Right? The second element, what should I write here?
2, sir.
2. And do I have to do anything else or is it done? Do I have to write anything else?
No, sir, the result is 1 cross 2 matrix.
So you can see that this matrix remained same. Right? So in general, when you multiply with an identity matrix, any matrix n cross n, and if you have an identity matrix I, you multiply whichever direction, it will always remain the same. So this is an interesting property with this identity matrix. I will leave this a homework. You can play with different kinds of matrices and it always remains the same. The matrix does not change. If you have an identity matrix where all the diagonal elements are 1 and everything else is 0, it always remains the same. And similarly, if you have a matrix of different size, not a square matrix, but some matrix m cross n, so to have a matrix multiplication, you must have identity matrix of size n cross n, right? Then only you can multiply with A. Then only n is equal to k will become. And you see that it will always be an identity matrix. And similarly, if you multiply identity matrix of size m, the other side, it will also remain the same. So this is a very interesting property. So this part. I just want you to look at this part that I just marked and see if you are able to understand this thing. And probably you have to try it yourself. I will leave this as a homework to you. to verify this is the case.
Okay, sir.
Okay. Okay. So this part is okay. Now let's move into something more interesting. Yes. So now we have this matrix inverse. Someone talked about adjacency matrix, right? I don't think we will do adjacency thing, but we will definitely talk about what matrix inverse is. So what it says is that if you multiply A into B or B into A, it should always become an identity matrix. Then only you will call the matrix B is an inverse of a matrix A. So it's simply something like this: A into A is some scalar. Say, so let's write scalar as S. Say if I write 2 into 1 by 2, is the value is
1.
1. So we call 1 by 2 inverse of 2, right? It's 2 to the power minus 1. It's the inverse of 2. And it became 1. So in scalar, when we call inverse, we simply say 1 by that number. So if you have some number lambda, and if you multiply by 1 by lambda, it becomes 1, right?
Yes, sir.
Okay. So this is why we call inverse. But in matrix, it's different though. Matrix is like such big numbers though. And when you multiply with 1 by this big number, how will you do 1 by this big matrix though? And it should become 1. This is the idea though. You want to make it equal to 1. But this is a matrix and this is a matrix. You cannot cancel this matrix, this matrix. It's a matrix though. This doesn't work this way. And multiplication is like you need to multiply with each row with each column. But is 1 by this big matrix. How will you do column here? So we don't do multiply the inverse like this. And 1, how did it become 1? It should become some matrix, right? Each element will become something. So what we define matrix is in this form. We define a matrix inverse A into A inverse should become an identity matrix. So if I say if A is of size n cross n cross n, this is n though, n, not m, n. And A inverse will also be size n cross n. Then only the identity matrix is always a square matrix, right? Identity matrix is always a square matrix because all the diagonal elements is equal to 1 and everything else is 0. So it is only possible when it is a square matrix. You cannot write a, okay, let me show you. You cannot write a diagonal matrix, everything 0. So you have 1 here, you have 0 here, you have 0 here, you have 0 here, 1 here, and 0. Is this a identity matrix? Is this an identity matrix? The diagonal element seems to be all 1 and everything else seems to be 0. But this is not a diagonal identity matrix because this element, you cannot identify the main diagonal, right? Because the main diagonal should have, like, the full element should be covered. So this is not a diagonal matrix, or this is not an identity matrix. A diagonal matrix, this is only possible, you are not able to write because here the size is 2 cross 3 and it is not a square matrix, it's a rectangular matrix. And similarly, if you try writing 1 0 0 0 1 and 0, is this a identity matrix? Is this matrix an identity matrix?
No, sir.
No, because here also you are able to see 1 1 here, but this element is always remaining. So here the size is 3 cross 2. Here too you are not able to write in an identity matrix. So identity matrix is only possible when you have something like this form: 1 0 0 1. It is size 2 cross 2. It's a square matrix and you are able to write an identity matrix. So in identity matrix, it must be always m cross m size, or something n cross m, k cross k. It must be both the row and column should be same. Otherwise, you will not be able to write identity matrix. Okay. So if you multiply A into B or B into A, it is becoming an identity matrix, meaning that it must convert into a square matrix. And it is only possible, inverse is only possible. So you can see if A is M cross, say, right, let's write A is M cross N and B is also, to have a multiplication, it must be N cross M. Okay. So if you multiply A into B, the resultant matrix will become M cross M. M cross M, right?
Yes, sir.
Similarly, if you have B cross A, so you the resultant matrix will become N cross N, right? Because B is M cross M and A is M cross N. MM will be cancelled and N cross N. It will become N cross N, right? But you see, you are saying that A into B and B into A are both equal. You're saying M cross M and N cross N are equal. It is only possible when M is equal to N, right?
Yes, sir.
That means that A and B are square matrices. That means that both the number of rows and number of columns are same. Then and only then A into B are equal to B into A. Otherwise, it will not be possible, right? If it is not true, M is not equal to N, then A into B is not equal to B into A. And similarly, if A is a square matrix, B is also a square matrix, therefore you can write a identity matrix. Identity matrix, we just saw that it must be a square matrix, and therefore we have a square matrix. So inverse is only possible for a square matrix. So inverse of A is only possible if you have a matrix of size M cross M. This is the condition. To even have a square matrix, this is one of the necessary conditions, that A must be M cross M. If you have M cross N, you cannot calculate, say, if a B matrix is of size M cross N, inverse is not possible. If your matrix is M cross N, inverse may be possible. Why I say may, we will see this thing, but inverse can be possible. But B does not have, B inverse is not possible. This is not possible. Is everyone okay with this?
Yes, sir.
Okay, sir.
Okay. So this is what inverse is, and this is what all it says. It's a no common notation is A inverse, A into A inverse, A inverse into A. They all result into an identity matrix. And how? But what about this? What is the value of this? If you inverse A into inverse, what will be the value? What is the inverse of an inverse?
Sir, A.
Yeah, yeah, it is A. So you can see this thing. So you have seen A inverse into A is identity, right? Now you want to find the inverse of this guy. So what we did was A into B was equal to identity. So if you multiply this, so how do I write this? Okay, let me write this. So you have A into B is equal to identity, and you called B is the inverse of A. We wrote it like A inverse, right? B is equal to A inverse. Then only this is possible. Everyone is okay?
Yes, sir.
Now we want to find A inverse into, say, some C should become identity, and we call it C is equal to A inverse of inverse, right?
Yes, sir.
And we want to find this. This is what AC is. C is A inverse of inverse, and this is what we are asking. look at this equation and this equation. So we have, first we have A into A inverse is equal to identity. Now we are asking what is A inverse, and if this is the case, and we also know from this part A into B is equal to B into A, so we can also write A inverse into A. I can also write A inverse into A, right? A into B, A into B is equal to B into A. So B into A inverse into A, and this is equal to identity. This is all are equal to identity. Everyone is okay with this?
Okay, sir.
Now look at this. What did we want? A inverse into C should be identity. We have A inverse into A is equal to identity. So therefore C is equal to A, right?
Inverse, the whole inverse.
And anyway, look at this. This is A inverse. So this we say that this is equal to A inverse C, and therefore, and C we know is equal to A inverse whole inverse is equal to A. Why C is equal to A? Look at this equation. C A inverse A is equal to A inverse C. Therefore, C is equal to A, right?
Yes, sir.
Can everyone see this thing? What I wrote. We first said A into A inverse is identity. We first said A into A inverse is identity, and since A into B is equal to B into A, so we wrote A inverse into A. B is this. B is A inverse, so we wrote B into A, and they are all equal to identity. They are all equal to identity. So we wrote A inverse, A into A inverse is equals to A inverse into A, and they are equal to identity. And we saw that what we want to calculate is C, which is equals to A inverse into C is equal to identity, and C is A inverse of inverse. And we placed it here, and we saw C is equal to A. So that's how it is. A inverse of inverse is A. Everyone okay with this?
Yes, sir.
Okay,
Yes,
so so I will just leave it here, and if you're not able to uh, understand, we can ask. You can ask me again tomorrow. And yeah, this is where the adjacency matrix came here. This inside thing. I will not go over this because now people there are better ways to calculate A inverse. This is a complicated way. So we just leave this part here. I think I will do this thing tomorrow then. I think we only have 2 minutes. We'll just leave it. So we have there's a few more, and then tomorrow we will just complete this linear algebra and then do Python hands-on tutorial. If time permits, then we will do machine learning again. But tomorrow we will do this part. I will just stop here. I will just wait if people have any questions for the topics that I've covered. I think today we covered a lot of things. So let me just stop here. Anyone any doubt? We only have 2 minutes though. I should have stopped much earlier. Anyone any doubt till now that I need to explain anything?
No, sir.
Okay. So if no one has any doubt, then we can end today's class, and tomorrow we will start from where we left. Okay.
Okay, sir.
Okay. Okay. So now we can end the class. You can leave. I will just wait till 7:30. Yeah. Thank you, everyone.
Thank you, sir.
Thank you, sir.
Hmm.